will give you the introduction of the history about bromide. Bromide was discovered by two scientists, Anton Ballard and Carl Jacob, in the period 1825 and 1826. Ballard found the bromide in the agar ash of the salt mass in the Lake Montpelier in 1825, and after doing a lot of distillation process, he discovered a new element called murite, which was later named bromide by the French scientists due to its specific smells. At the same time, Jacob isolated the bromide from the mineral spring in his hometown. He separated the bromide by the de-ester, and after evaporating the ether liquid, he obtained a reddish-brown liquid. Unfortunately, his publication was postponed because Ballard published his announcement sooner than him. Bromide is the third chemical element of the halorane group, designed as PR. It's a reddish-brown liquid and has the same color when evaporated. Because bromide reacts so strongly, so it doesn't exist in free element, but only a form of halorane group salt in the atmosphere.
Hi teacher, my name is Thuận, and I will take care of the next part after Kim Win's presentation. My part is about bromine's physical properties and natural state. Bromine is a non-metallic, which is heavy and toxic. It exists in the liquid state. At room temperature, it is a dense, deep, reddish-brown liquid with sharp smell and causes severe burns when contacting directly with the human body. It evaporates easily, giving up strong fumes that irritate throat and lungs. Bromine has a melting point of -7 degrees Celsius and a boiling point of 58.9 degrees Celsius, and its density is 3.1023 grams per cubic centimeter. Bromine is soluble in water, but more soluble in ethanol, benzene, and gasoline, etc. A water-soluble bromine solution is called bromine. Bromine exists naturally in the form of compounds, mostly bromide salts of potassium, sodium, and magnesium. The content of bromine in nature is less than chlorine and fluorine. Metal bromide is found in sea and lake water.
Teachers, my name is V, and today I want to tell you some chemical properties of bromine. As you know, the bromine has many chemical properties. The first one is reacts with metal, halogens, hydrogen, air, and the final one is water. As you know that it is less reactive than chlorine and fluorine, but more reactive than iodine because of its position in the periodic table. Now we've moved to the first reaction. It's the reaction between bromine and metal. And the typical metal I want to tell you is the aluminium. Bromine reacts with aluminium, forming aluminium bromide. Aluminium bromide is hygroscopic in fumes and forming a white cloud that looks orange because it's mixed with bromine vapor. Move to the second one. It is the reaction between bromine and halogens. It includes three elements. This is fluorine, chlorine, and the final one is iodine. Bromine reacts with fluorine, forming bromine fluoride. The product is very difficult to obtain poor, as bromine fluoride reacts with itself and forming bromine trifluoride and forming benzyl fluoride. Besides, when we add fluorine at 150 degrees Celsius, bromine will react with fluorine, forming bromine benzyl fluoride. The next reaction is the reaction between bromine and chlorine. Bromine reacts with chlorine, creating the unstable bromine chloride in the gas phase. And the final one is bromine reacts with iodine at room temperature, forming bromine iodide. Well, my part. Thank you for listening.
Hello teacher, my name is Thuận and I will continue technique part. I will talk about the last three chemical property of the bromine. Okay, let's get started. The third property is bromine react with hydrogen. The bromine react with hydrogen to create hydrogen bromide. Hydrogen bromide is soluble in water and it creating hypobromic acid. And this is strong acid, it's even stronger than hydrochloric acid. Okay, the fourth property is reaction of bromine with air. Bromine is not reactive toward oxygen or nitrogen. However, bromine does react with ozone, the second atom of oxygen at -78 Celsius degree from the unstable oxide, bromine for dioxide. And the fifth property is reaction of bromine with water. Bromine reacts with water to produce hypobromide. The position of equilibrium depends very much upon the pH of the solution.
Hello teacher, my name is EK. Today I will undertake the application of bromine. Due to its unique properties, bromine is applied in many fields with many different purposes. Firstly, bromine produces hydrocarbon derivatives such as bromelton and dibromelton in pharmaceutical industry. Secondly, a huge volume of bromine is used to produce silver bromine, which is highly sensitive to light and develop films. The effects of light degrade silver bromine into silvery metals in black powder form and bromine in vapor form. The chemical equation presented is argentum in the appearance of light, forming argentum and bromine. Thirdly, bromine is also used in agriculture. Organic bromine compounds are used as insecticide to eliminate insects as well as harmful organisms and kill rodents. Fourthly, bromine is used in pharmacy, the manufacture of dye and printing inks. And another possibly lesser known use of bromine is its ability to be antiseptic, which sterilizes the water of swimming pools, and is considered to be more effective than other antiseptics.
Teacher, now I'm gonna be in charge with the last part, how bromine is produced industrially. So as we know, the Dead Sea play a significant role in providing the raw material for bromine and its compound. And the route from the Dead Sea waters to bromine and its compound illustrated in the scheme below. At the scheme, bromine is produced from brine present in the evaporation pools after separation of most of the sodium chloride and potash. The bromine production process in Israel was discovered at the beginning of the 19th century, and the industrial production process of bromine resembles the laboratory process in principle and involves the direct reaction of chloride with brine rich in bromine ions. The process is fast, simple, and relatively economical. Bromine production in Estem employ the hot process based on the direct feed of chloride and steam, as well as Dead Sea brine rich in bromine ions into the reaction tower.